Yesterday we agreed that we'll start by checking 9 and 10 before we can start to talk about derivatives of inverse trigonometric functions. Can you see that?
Yes, sir.
Can I request you to share with us what you found as an answer for number 9?
Okay. For number 9, the answer that I got was pi second squared pi x.
Whoa, hey, can you see that?
Yes, sir.
This car will make a big accident when it crashes.
Okay.
When it travels at this high speed that it is traveling with.
Okay, sir.
Is pi
second squared pi x
sec squared pi x
times 10 pi x open bracket 6 plus second pi x squared.
6 plus second open bracket 6 net
Yes,
plus secant squared
pi x close bracket.
Secant squared pi x. Then we close this bracket.
Yes, sir.
Can I repeat what you just said? You said to me I should write pi sec squared pi x times tan pi x open bracket 6 plus secant squared pi x close bracket
to the power of negative 12. Sorry about that.
to the power of negative 12.
Yeah.
This is
12,
for number 9, right?
Yeah.
Number 9, yes.
Okay.
Can you see that?
Yes, sir.
Please talk to the family members.
Okay. What did you guys?
Please, anyone, can you?
Okay.
Can you see this answer is pi secant squared pi x times 10 pi x open bracket 6 plus secant squared pi x close bracket to the power negative 12.
All right.
Then you can talk to them. Can you see that?
Did anyone else get a different answer from what I got? If anyone did, can you please share?
Yes, I got a different answer.
Okay, what did you get?
I also got a different answer.
I got
I also have a different answer.
Okay.
like I have 2 answers, but I only say one. Yeah.
Okay.
It's the truth.
Okay, what did you get?
The first answer that I got yesterday at night during the windy night was secant pi x squared times tan pi x squared.
Hang on, Lerado. Let me write. Let me get my pen closer to me in my hand. Okay, this is Kanyisile. Now, Lerado, please come with your answer.
The first one is secant pi x squared tan pi x squared all over.
Not that fast, please. Secant
pi x squared
pi x. Is everything all squared?
Yes, all squared. I always use the big bracket so that I can see not what.
Okay,
and
in bracket, then squared, yes.
And then tan pi squared.
Tan pi squared.
Tan pi x squared.
Also inside the bracket, everything squared.
Yes.
Okay.
And then all over
all over
2 times square root of guys, can you hear me?
Yeah.
Yeah, we can hear you,
2
Lord.
times 2 times
Square
the square root
of
what?
6 plus sec squared tan x.
Okay, it is all over 2 the square root of 6 plus sec squared tan x.
Yes, that's the first one.
Yo, okay. Number
The
one.
second one. Second
Mhm.
one.
Actually have more than one answer.
The
The
second
second
one,
one,
I trust it.
okay.
It's pi x second squared pi x.
Pi x second squared pi x, yes.
Tan squared
Whoa.
x.
Whoa. Pi x second squared x pi x. Is it times?
It's the same expression with tan squared
Oh,
tan
you are
x.
multiplying. Oh, meaning
Yeah.
I should write tan what? Tan what?
Whoa.
Tan pi like tan squared pi x.
Tan squared pi x. Okay.
Yes. Then the
Mhm.
denominator is only the square root of 6 plus second pi x squared.
Lerato.
6 plus second squared pi x.
It's 6 plus second squared pi x, yes. The denominator
Okay.
square root of, yes.
Okay. There is someone who's talking. Let me finish with Lerato, then you'll come in. Lerato, then this is your second answer. In
Yes.
the numerator, you said pi x secant squared x pi x tan squared pi x. Okay.
Mhm.
All over the square root of 6 plus secant squared pi x.
Yes.
Okay.
Sir?
Now, between these two, which one should we consider?
Sure.
Like say, I don't like to choose in between my answers.
Okay.
So can I help?
Are you the one who have been calling me?
No, the
me.
same thing Theo wants to say. So I'm gonna say it too.
Oh, okay.
This is
Okay.
exactly what I'm going to say.
Whoa. Hang on. Okay, let's say the first. Who was the first? Was Fiona?
It was
Yeah.
me.
Okay, then followed by Sibusiso in that order. Okay.
Okay.
Yes. Sir.
Yes.
I disagree with that answer as well, but I'm gonna ask for a favor. And not to sound thick, but so would you mind just repeating everything he said in the numerator for the second answer?
In the numerator.
In
For
the
the second
numerator.
answer.
Denominator I got. Okay, I heard that, but the numerator was like kicking me sideways.
Okay. Pi x
Yes.
secant squared x pi x.
Okay, so you said it's secant squared pi x.
Secant squared x pi x.
Okay.
Multiply tan squared pi x.
Okay, thank you. I disagree. With both
Theo,
the answers.
fix it. Yes, I know you disagree. Fix it. Point out the issue. Point out the issue. Point the issue.
I say the answer that is mine.
Okay.
Okay. My answer is as follows. In my numerator, I've got x times pi, which is x pi, obviously. And then...
Whoa, hang on, my brother. Do you agree with the numerator?
Nope.
Leonardo gave me two answers here.
I disagree with all of his answers.
The second one is correct. Remove the x.
So you know what's the interesting thing about your answers? The interesting thing about your answers is with the first answer, seemingly with the second answer, I agree with the denominator, but not the numerator. And with
That's
the first answer, your numerator is kind of sort of agree with it, but the denominator is a no.
Yeah.
Yeah. So with one answer, the one seems fine and the other seems wrong. Well, in my opinion, anyway. And with the other answer, the one seems wrong and the other seems fine.
Say the right answer.
May I
Say the
please?
right.
I'm not going to say the right answer. I'm going to say the answer that I got. Okay, my answer is as follows. In the numerator, I've got x pi, and then we open a bracket, and then we've got secant, and the angle for secant is pi x squared. And then we've got tan, and the angle for tan is pi x squared as well. And that completes our numerator. In the denominator, we've got the square root of 6 plus secant, and the angle for that is pi x squared. Done.
Thank you. That's the answer. Thank you. Thank you.
What's the answer? Say
That's
it.
the answer.
I'll do you one better. I'll even post it in the chat. How's that? Because saying
That's a good idea.
is going to give all of us mental brain freeze.
Yeah, can you please?
Hello, no, I agree with you on the denominator.
Okay, and the numerator?
Numerator, I struggled. I got X only.
Okay, okay.
Yeah.
I'll post my solution, and then we can all talk about it. And again, it could be wrong, as we all know. And if it is, and if don't worry, you know I'll post it.
Theo, what did you get for your numerator?
Don't worry, I'm about to post it, so you'll see it.
Right, because I redid my working.
Yes,
Okay,
Lord.
give it a few seconds. Yeah, I think it's done. Check.
Sir,
Hello.
you must be arrested for writing my answer in the wrong way. Like this.
I've posted my solution.
Brother, I wrote what you told me to write.
There's no second x pi x squared. It's second pi x squared. There's no x.
Legato,
Wait.
you're the one who said secant squared pi
You did say
x.
that. Yes, you said secant squared pi x squared or something. Yes, you actually said secant squared pi x, and you said tangent squared pi x. So Dr. Glenn actually took your answer correctly, because that's why I kept on saying, please repeat, because I wanted to make sure that I was hearing this correctly as well.
But it's like that. The only difference is the start where I said pi x.
Okay.
It does exist.
I redid my working out and I got what you got on the picture.
Then that's great. That means
Yeah.
we're all.
I found out where I went wrong.
Okay.
Theo.
Theo.
Yes, Lord.
Yes.
Theo presented something wrong here.
No, I didn't.
It's 1/2, not half times 2x. 1/2 must be down when you cancel.
Yeah, Legato, there's a square root there, man. You need classes, I see, man.
Lerato, can I ask you a question? What is half times 2x?
It's 1.
Thank you. And what's 1x? Do you not see the 1x there? Thank you. Go on. Try me again, please.
We agree on this one.
Try me again.
Number 10, second round. It's not over. We are coming back.
Don't worry.
Okay. Okay. Now,
Agree.
what is the consensus?
Oh, sir, before we continue, may I please say something as a disclaimer?
Yes, I'm not continuing because we still have to agree on what you posted, whether everybody agrees or disagrees, and then we also come to Lerato, then we conclude.
Yes, but before we continue, I just wanted to say as a disclaimer that the colleagues must just know that this is just friendly banter between Lerato and me. It is very friendly banter between two gentlemen of stature.
I understand.
Thank you.
Members, I'm still on my list. I'm still having Erika, Kanyisile, Lerato, Sposiso, Theo, and Voyo. Has anyone joined? I don't want to leave anyone out.
Tando has joined.
Tando is here.
Mhm.
And who else?
Makwin.
Mhm.
Yeah, Makwena is here. Because
Yeah,
Tando did say that Tando said she disagrees with my numerator, right?
Yes.
Oh yeah, she did say that.
Yeah, I think she said she
Yes,
got
yes.
Okay, now let me ask in this way. Does everybody agree with your answer, which she posted?
I agree.
Erika
That's
agrees with him.
Erika, can you see that? Sposiso?
The question is, who disagrees?
Oh.
Okay. Okay. All right. I got that, Sposiso. Now, let me talk to Tando disagrees. Tando will be the last. Let me talk to Makwena. Makwena?
No, sir, I don't disagree, sir. I said I agree only on the, I said on my numerator, I struggled. So I want you to explain
Okay.
for me the numerator later.
No, we can do it now. We'll do it now.
And then, yes, we'll do it now. There is Vuyo here. Vuyo?
He said something about his mic. He's having issues with his mic.
Oh, okay.
Yeah.
And he left now.
And then Makwena,
Yes, sir.
how are
Mina,
you?
I'm good, thanks. How are you?
Yeah, Mena, what now?
Okay. I'm still looking at his solution, ne?
Okay.
But okay,
But-
I got something very different from his. I got pi sec pi x squared 10 pi x squared over. We have the same denominator. We have the same denominator. I don't have x. You see
Okay.
where he has pi. I don't have x.
Okay. No, it's
I don't
fine.
know how.
No,
Let me look at the
I-
maybe I
I-
will.
I think I
Okay,
might know one of the same
while
answer.
while you are looking, then can I request Tando and Theo to clarify the numerator? And then
Yes.
Makwena, while she's still checking, hopefully when the two are finished, then she would be done then, so that we can continue.
Okay.
Theo and Tando.
Is this the time where you say it's time for you guys to dance?
Yes, please.
All right. Hey, Tando.
Hello, Theo.
Cool. Are you ready?
Yeah, I'm ready.
Okay. Hopefully, I can explain it in a way that it makes sense. But anyway, so the first step that I did, I took the square root and I converted it to an exponential function, as you can see, right?
Yeah.
And so by doing that, my first step was, okay, I've changed the square root to a power. And then I was like, okay, now I've got the chain rule, right? Then I brought the half down and then I minused 1. So that part you follow, right?
Okay.
Because according to the chain rule, you differentiate the outside, leaving the inside the same, and then you get the derivative of the inside. And so to do that initially, the half comes down, and that's bring the half down minus 1. So I end up having half times whatever was inside the bracket, and then it's to the power of negative half because I get the half minus 1 ends up being negative half. Are you with me?
Yeah.
Okay, cool. And then the next step now says you multiply with the derivative of the inside. And then what's the inside? The derivative of 6 is 0. And then it's plus the derivative of secant, when whatever the angle is to secant, is the derivative secant is secant tangent, right? So it becomes secant pi x squared, tangent pi x squared. And then now the next step is now to get the derivative of the angle. And our angle in this case is pi x squared. And the derivative of that, and remembering that pi is a constant, so we keep pi and then we derive x squared, so it becomes pi times 2x. And so what we end up having in the end is y prime in my case is equals to half times what we had inside the bracket to the power of negative half, and that is all multiplied with secant pi x squared, tangent pi x squared, multiplied by pi times 2x. And then after that, it's just basically sorting stuff out. And then I then took the half and I multiplied it with 2x and pi, and then that left me with a half times, that left me with a half time with pi times x. And then I took what was in the bracket because it had a negative power to the bottom, so that I made that power positive. And then after that, I changed that back to a square root, and then whatever was left, I left right there at the top. Literally, that's what it is. Because I feel like after the part where we get our derivative, the rest is just sorting, literally. I hope that makes sense.
Okay, yeah, it makes sense. Thank you so much.
Are you sure? Okay.
Okay, thank you. Thank you, Theo and Tando. Magwena,
Yes, sir.
yes.
Thing is, Mina, I took sec squared x as, I didn't take that as an angle. I made it as, let me just send my solutions on the chat and then explain them, because
Please do. Yeah, please do. Then we can go over it
Okay.
together as a team. She just posted it. Okay, let's see. Okay. First step. I mean, we all agree with that. Change the square root to a power situation. Bring it down. Minus the half. Good. So second step so far, it all looks great. And then she's supposed to multiply with the derivative of the inside. I think that's where we lost it. 6 becomes 0. That's fine. Secant pi x squared should then be secant tangent, which should be secant pi x squared tangent pi. Okay.
Like the pi is in the front. Not
Yeah.
at the
And but not so the pi is in the, yeah, I see it too. So the pi is in the front, not at the end, but also the problem with it is it's not, it doesn't have an x squared because it's supposed to be, I think it must be pi x squared. Okay, so
Yes.
she was coming along fine. The only issue occurred when she was computing the derivative for what's inside the brackets, basically. And then
And
that,
also the chain.
yeah, because the 6 is fine, that disappears. Then we have secant pi x squared, which is fine, and then the tangent was supposed to be tangent pi x squared. And then after that, she was then supposed to derive the angle, which was the pi x squared, and she was going to get pi times 2x. So, okay.
Oh, yeah.
Yeah, if she had gotten that, the rest would have been easy because she got everything else perfect, actually.
I said that.
So, I mean, you guys will tell me, but I think the only place where she got confused was when she then had to
What are
derive
we?
the angle of secant squared, of secant, the angle of secant.
Okay, let me keep quiet.
I took the secant squared as, that angle I took it as if the whole thing is squared.
Oh, is that what you did? Okay. Whereas,
So my angle became pi x.
I see. But then, do you see how? And I stand to be corrected. But do you see how all of us looked at it? So all of us, we saw secant, and then the angle was pi x squared.
Okay.
Yeah.
That's
Whereas, look at it this way, and we did a similar thing yesterday, where if secant was the one that was being squared, they would have put the squared after the secant. Think about it that way. So they would have said secant squared, and then they would have given us pi x. I hope that makes sense.
It makes sense.
Okay, but thank you for sending your solution, because at least this way we can all actually see where you went wrong. And again, everything else is perfect. It's just that one thing that threw you off, as far as I can see anyway.
Thank you so much.
No, Makwena, it's all good. It's what we do here. We all work together as a team. Thanks for sharing.
Tando, this is what I'm saying. You were here with us yesterday, ne?
Yes, sir.
Yes. Was Ishmael with us yesterday?
Ishmael, I think he's the one who was participating well. Yeah.
Yes, he was here. Now, can I ask you and Ishmael to talk to each other? And then once we have spoken to each other, then you can talk to us about the answer for number 10.
Hello, Ishmael.
I think
Ishmael,
he still has issues with his mic.
Yeah,
he skipped
he's
out.
still sorting it out.
Yeah. You wrote that on the chat.
Yeah. So Tando, you're gonna have to pick somebody else.
Pick any other person.
Yeah, Spusiso.
Yeah.
I definitely saw this one coming, Shem. Tando, what's your answer?
Like yours, Spusiso.
Like mine.
Yeah.
Okay. Tando, I have -12 times cot squared bracket 4x plus 1 times secant cosecant squared bracket 4x plus 1.
Mm. Mm.
Okay.
What have you got, Spusiso? Please repeat.
-12 cot squared bracket 4x plus 1 close bracket times cosec squared bracket 4x plus 1.
Tando, did you capture that?
Enough.
Tando, did you capture that?
No, it's
Knock,
different,
knock.
but at least if Spusiso is winning, I'm winning also because in it.
Yeah,
no,
Tando. Hey, welcome, Abdul. How are you?
How are you, sir? I'm alright.
Good, and
Yourself?
We are okay.
And I'm not at 100% okay, sir. Have we discussed the answers from yesterday? Because I'm about to also go off in a few minutes' time.
Oh, yeah. Let's quickly do this. Can somebody, okay, Tando,
Can you
will
give
come.
us his answers for number 9
Oh,
first?
oh, okay. Oh, okay.
Okay, for number 9, what I got in the numerator is negative pi x tan in brackets pi x squared multiplied by sec in bracket pi x squared all over the square root of 6 minus sec in brackets pi x squared. That's number 9.
Interesting.
How did you get the negative?
Yeah, your negatives.
My negative is coming from when you derive, especially in sec, there is a negative there, especially that negative.
Nah,
from
sec doesn't
sec.
have negative.
It's cosecant that has a negative.
Cosecant.
What I'm trying to say is, remember under the square root, we have 6 minus sec pi x squared. So there is a negative in front of that sec. It's 6 minus, in my case, how I viewed it, is a negative.
The question said
okay.
6 plus.
I wrote it down as 6 minus sec pi x squared.
Okay.
And then for my number 10, I got
Whoa. Tando must tell us a number 10 first.
Abdul is going to be off now, guys. Let's give him a chance.
Thank you
got,
very much,
Tando. 15 minutes.
I don't have that much, guys. Like at any time. That's how I wanted to make sure. Can I share number 10 with this family? And then my number 10 is negative 12 cot squared bracket 4x plus 1 close bracket multiplied by cosec squared open bracket 4x plus 1.
Marvelous, my man.
Thank you very much, family. And then, sir, as for today, what are we probably going to be covering so that I can also make it a point that I just follow through when the electricity comes back so that I'm on par with you guys tomorrow?
Okay, when we are done with number 10,
yes, sir.
We are moving on to this section that is called derivatives of inverse of trigonometric functions.
Yes.
All right. All right. Thank you very much, family. I will definitely be in touch with you guys. Now of Utamaide Mtakasi, so it's just a matter of me saving this small Anyana battery. I'll see you guys tomorrow. I love you all.
We understand,
Peace.
brother. Thank you.
Mr. Abdul, what a legend.
We really appreciate.
Yeah.
I appreciate the effort taken by Abdul, even though he's under a difficult situation. Let me also thank you for understanding the situation under which Abdul is currently finding himself under now. Thank
Yes. Now let's point back to Tando. She called my name, so I'm gonna be on her head.
Wow.
Yeah. Tando,
Hello.
that's your answer, man.
Your mind, it's -3. Then open bracket cot of 4x plus 1, close your bracket, then all squared. Then over sine squared, multiplying, all over. -3 cot plus 1 squared, all over sine squared, 4x plus 1. I left.
How did you get your answer?
Hmm?
How did you get your answer?
And you see it's cot cubed of what? Of 4.
Tando,
4x plus 1. So, I mean our y. Once we are deriving the y is equal to cot cubed of 4x plus 1. So what I did is I said 3 multiply cot of 4x, then I subtracted 1 from that cot. So I got squared now. Then I multiplied by the dx of cot 4x plus 1.
Okay, Tando. Can I ask a simple question? Why did you change cosecant squared to sine squared?
Yeah.
That it's cosecant or it's cot? Maybe I copied it wrong. I said cotangent.
Okay.
Which means
Let's go over it slowly, Anna. Let's go over it slowly. Anna?
Yeah.
Okay. In the question, you have cot cubed bracket 4x plus 1. Right? So we basically use the chain rule because the x cubed applies to everything. And it's
the cube applies to
everything. It applies to cot bracket 4x plus 1 bracket, then all bracket cubed. Are you following?
No.
Okay, open a big bracket. Right cot bracket 4x plus 1. Inside that bracket. Then outside that big bracket, place cubed there. Okay, now let's do the chain rule. We bring down 3, then we subtract 1, right?
Okay, 3 then cot 4x plus 1. Then all to the power of what? Of 2.
2, yes. Then what we do? We multiply by the derivative inside the big bracket, right?
Which is what? Which is 4.
Are you following, sir? Now, which is, we are multiplying by the derivative of cot this time, cot.
Okay.
Yeah.
Cot. So it will be what? Cosecant.
Negative cosecant squared. Then whatever the angle we have in cot, we place it exactly as it is.
Squared, yes, I did that.
Okay. Then we multiply by the derivative of the angle of cosecant squared, which is 4. Are you following?
Yeah.
Then that 4 will multiply the negative 1 of cosecant times 3, which is negative 12.
Or that 4 will multiply
3 and that negative from
or 3 and that
cosecant.
negative. There is no numerator.
If you change cosecant to 1 over sine squared, then you have a numerator. That's why I was asking you why you changed the cosecant to sine squared. But don't change it. Don't change it. Yeah, don't change it.
Yeah.
Are you
But I
following?
changed me sine squared and cot.
Okay. So
Yeah,
what
so-
you have now, it's negative 12 cot squared bracket 4x plus 1 times cosecant squared bracket 4x plus 1. Angithi?
Cosecant what 4x plus 1 squared also.
No, plus 1. Yeah, cosecant squared bracket 4x plus 1.
Okay. So that is our answer.
Yes.
I think
The
even
important
Sam
thing,
has to
did you
ask.
follow the steps?
Yeah, I wrote everything down.
Do you understand how we, piece by piece, the chain that Theo always talks about?
Yeah.
Yeah,
Thank you so much, Sibusiso.
you're welcome.
We are winning, sir.
Thank you,
That is
Sbusiso.
our answer.
Thank you, Tando.
Thank you, guys. Thank you so
Sorry?
much.
Is your answer similar to this?
Yes, it's the same.
Okay.
All of them are the same.
All of them are the same. Okay. I'm happy to hear that. Now, can we now move on to this section that, okay, before I step off this, are you comfortable in handling this type of exercises?
Yes, most definitely, sir.
Do you promise me that you will not disappoint me next month during that critical time?
You see, sir, with derivatives, we won't disappoint you, sir.
Limits, I'm not sure.
H limits, yeah, even me. Hey, limits. Derivatives and okay. Hey, it's limits, man. Hey.
That's
People, the same thing you're doing with derivatives is the same thing you're doing with limits, most. The
We
difference is
discussed-
that you're just finding the slope with derivatives using the method of limits.
Mr.
Okay.
So,
That's
hey,
smart.
please say that again.
People,
Please say that again.
say what?
What you just said about what you just said now, where the thing, yes.
Okay. You remember limits
Mhm.
are when you approach a certain value.
Yes.
Then derivatives
Mm.
are formed from that idea of limits.
Mm-hmm.
Yes.
Oh.
Exactly.
Oh.
So the same math applies, just that you're applying the laws. This time you're just finding the gradient of the slopes of graphs and so forth. Take it as finding the slope of how the mountain is steep or something like that. That's what you're doing. And you're doing that by applying the idea of limits. Just that you don't say limits this time.
Okay.
Damn. Thanks. Wow. Oh, wow.
Thank you, Sbusiso. My request is that the sections that we have covered, that's my humble request to say, those sections that we have covered, please just make sure that you collect maximum marks. Please. I'm pleading with you.
Sir,
Yes.
By maximum, you mean everything.
Hello.
You mean everything.
Sorry?
When you say when you say maximum max, you mean all these sections you must get everything.
Please. That's my request.
I promise you, first principle, derivatives, I'll get that 5 marks. I promise you now. The rest, I'm not sure.
Sure. Lerato. Okay. Let me go back. Spusiso gave me a friendly advice. I'm taking it. I'm taking Spusiso's advice.
Go ahead, sir.
Sorry? Yes, for the sake of my health.
Yes, sir.
Yes.
Lerato is very stressful, sir. He stresses me.
Lerato.
No, sir. Everything on the limits. Fine.
Lerato.
Yes, sir.
I learned something during the course of this week. Ne?
What?
I'm about to share it with you. I learned that there is a soul and a spirit. So now, if the spirit disconnects from the soul, then it becomes a big problem. So can I request your spirit and your soul to be in the same place?
In the same place.
Yeah?
It's in the same place.
Are they in the same room?
Yes, same room. Like,
Okay.
like, you know, man, how exams are, man.
But don't panic.
Like,
I don't know how many times I've said this.
That final question, which is more difficult than all questions combined in every section. That's the one I'm worried about.
That's the fun one, man. That's the fun
Lerato, I said it several times. That the intention of the examiner is not to trick you. It's just to test how far you have gone in understanding the syllabus. And that's it. Okay. Now, let's go to page 409. Derivatives of inverse trigonometric functions. Yes, there at the top, they started by introducing them, but they introduced them one by one. So the most important thing for me is to talk to you about this entire table, where from, I think, page 390 something, that's where they start talking about them, but at the end showing how they derive them. But the most important thing for you is just to know their application. Now, they're saying, okay, now, do you remember those other derivatives that we have already spoken about? Those that you have been applying?
Yes, sir. Most definitely.
Yes.
They are encrypted in our brains.
Thank you, brother. Now, please also encrypt these ones.
Already encrypted.
Okay, thank you. Now, the derivatives of inverse trigonometric functions. The derivative of the inverse of sine of x is equals to 1 over the square root of 1 minus x all squared. Then the derivative of the inverse of cos x is equals to negative 1 over the square root of 1 minus x all squared. Do you see the difference between the derivative of the inverse of sine and the derivative of the inverse of cos?
Yes, sir.
What is the difference?
The one Negative sign.
Thank you. Now let's continue. The derivative of the inverse of tan of x is equals to 1 over 1 plus x squared. The derivative of the inverse of cot of x is equals to -1 all over 1 plus x squared. Can you be able to see the difference between the derivative of the inverse
Yes.
of tan and the derivative of the inverse of cot?
Yes.
What is the difference?
-1, sir.
Thank you. Now, the derivative of the inverse of sec x is equals to 1 over the absolute value of the square root of x squared minus 1. The derivative of the inverse of cosecant x is equals to -1 over the absolute value of the square root of x squared minus 1. The same question applies again. Are you able to see the difference between the derivative of the inverse of secant and the derivative of the inverse of cosecant?
-1 again, sir.
-1 again.
Thank you. What about the others?
The difference is always -1. Then the other difference between sine, cos, and secant and cosecant is that cosecant and secant have the absolute value of x, and it's the square root of x squared minus 1. And when it applies to sine and cos, it is 1 minus the square root of x
Squared.
squared.
Yes, sir.
Please. Oh, okay. Yes, Lerato.
Why those two and the square root don't just cancel there?
Which one and which one now?
Square root cancel x squared. Squared
Because
cancel.
Lerato, x squared, you have 1 minus x squared. That's one term. Minus and plus, don't act like division and multiplication. You can't separate and apply the square root to x squared, leaving 1. 1 and minus x squared are one thing. They are one term. You just
Inside
don't
the square root.
inside the square root.
So there's no difference of two squares there
No.
No.
in the
I
square
agree.
root. Okay.
Oh, you wanted to take the difference of squares?
Yes.
Sure. Lerato. Yeah, it shows that, hey, I can never be safe around you.
Lerato is too much knowledge, which confuses him.
Because
Too much.
when you say
Too much.
derivative of inverse trigonomic functions, I was shocked. It was something I did not expect.
Dali, man. Dali.
What did you expect?
That substitution, that's why I'm confused.
Substitution.
Yes.
The one where it says sine squared x is equal to square root of a plus, you know it, man, say. You did it a long time back, like 15 years back. So
And therefore, you did it a long time back. You know it.
Let's pass, Lerato. Leave it, Lerato. Let's move on and we'll see what we need to know right now.
Yes.
an important question, sir.
Yes.
When you remove and the absolute thing, you always place the negative before the bracket.
When you
Remove up like negative like absolute of x is equal to negative times bracket of x.
Lerato, you know, when I talk to you, I need to be careful.
The thing is, I
Okay.
see it every time on past papers. They put negative, then remove absolute. That's why I'm asking.
Elagato, so can I take over, Sam?
Okay.
Okay. Elagato, let's start here. What do you know about the absolute value of
It's
something?
It's always positive.
It's always positive. Okay, I say yes, he's right, sir. I want to correct him, sir. Okay, Lerato. It's always positive, right?
Like absolute of
Yeah,
negative.
it's always positive,
Yes.
right? So, okay. So if it's always positive, let's say x is approaching negative infinity. X is what? For every term that x is approaching negative infinity, x would be negative, right?
Yes.
So for us to have a positive x, what do we do?
You put the absolute value.
No, Lerato, you'll put the minus sign. You'll put the minus sign so that for whatever value of x, as x approaches negative infinity, becomes positive.
Okay.
That's why you put the minus sign. If x approaches negative 2, when you place 2 in terms of x, you want 2 to be positive, negative 2 to be positive. So you'll put the minus sign in front of x. So when you substitute that negative 2, it will multiply with the negative, then it becomes positive.
Okay. Like, say, now I understand where I got this from. It was in a question. It was to the limit of negative infinity. But it's fine now. Yeah, it's fine.
Okay. I hope, Lerato, you are just not confusing things. Let me request you not to confuse things. Know when to do. Know what to do and when. Again, my simple statement. Please don't be an original mechanic. Be a professional mechanic. Okay. Know what to use when and where. That is a friendly advice that I can give. Remember when I made an example of saying it doesn't mean that each and everything needs a hammer or what?
Yes.
So, yes. Some other things just need you to talk to a neighbor. Say, neighbor, how is it today? You may find that even now you don't know who's your neighbor. Okay. Whoa, what am I doing now? Okay. Can everybody comfortably be able to apply these derivatives of the inverse trigonometric functions?
So I'm gonna comment this.
Yes, brother.
They won't comfortably apply those things. It's not comfortable to apply inverse derivatives. So it needs hardcore thinking. So yeah,
I agree.
this
I
one needs a hammer. So this one doesn't need a
hammer,
hammer.
a gentle
It
touch,
needs true
and
understanding of numbers. So yeah. That's my advice, people. Go with an open mind.
Yes, with an open mind.
Yeah.
Take it as it
Sir.
comes.
Yeah.
Yes.
Sir,
Yes, Lerato.
if you are telling me that when I see derivative of inverse of sine x, I must place that thing, then I'm fine.
Yes.
I'll do it.
Mm.
Then
Yes.
it's simple.
Yay.
It's substitution, then maths. Let's move on.
Lerato,
Okay, thank
it's
you.
not always that simple because sometimes you need to see the 1 over the square root and replace the inverse of sin in there.
It's fine.
This section
Okay.
already-
All right.
this
Can
section-
we? Lerato said it's fine. Somebody is talking behind, please. Please
Let's
say what
move
you need
on.
to say. No, Lerato, we can't move on. You were talking and then
That's what-
somebody was talking at the back. Let's
They
hear
said
what
we
that
must
other.
move on.
Oh, said we must move on. Okay,
Yes, it was
thank you.
Theo.
Lerato. Okay. Please find the derivative of the inverse of 10 of x squared.
My answer is 2 over 1 plus x over 4. I mean x to the power of 4.
McQueen, I think you forgot the 2x on the top. So you need to get the derivative of the inside of 10. The derivative of inside of 10 is 2x. But other than that, me and you have the same.
Isn't it squared?
So sorry?
Isn't it x squared?
Yeah, so but remember on the top you have to put the derivative of what's on the
Oh,
inside of the
yeah.
function. Yeah.
Okay, yeah, I see what you're talking about. I should have got 2x over 1 plus x to the power of 4.
That's correct.
Yeah.
So, what are you saying to us, the two of you?
As
What is the
2x
answer?
The answer is 2x over 1 plus x to the power of 4.
Yep. Yeah.
Please talk to us.
Yes, I agree with that.
Yeah, you two agree,
Oh, sorry.
but we don't know about the others. Talk to them.
Colleagues, do you agree with us?
See, Lorata's got her hand up.
Like me, I'm just shell shocked.
Oh, okay.
No, I don't agree also. I don't know, maybe that one.
Landed like a bomb. Just landed.
Okay. You know what? Nah, I would say, may I ask something?
Yes.
Mr. Ishmael, would you mind taking us through how you got the answer?
Okay, so I used my trick stuff again.
Yeah.
So let me just see if I can get a picture of this quickly and put it on the group.
All right.
What was his answer?
The answer was 2x over 1 plus x to the power of 4.
Okay, I got the same thing.
Let me just see if I can get this thing on here.
Yes, I agree, sir.
Okay, can you guys see that picture?
Not yet.
Let's see. Okay, I remember this.
Okay, so if I can talk you through it. So if you look
Please.
there, you've got this on the left hand side, you've got the three functions sine, tan, and sec. So what you need to remember there is for the so think of the S. The S looks a bit like a square root. So then you know that then it's gonna all of them are always the derivative of the ins of u over, and then for the two s's you have square roots, and then the tan is like a plus sign, so it's 1 plus u squared, and the others are minus. The only one that's tricky is that on the sec you've got to remember that it's basically swapped around from the sign in terms of u squared minus 1, and then you've got the absolute value of u on the side. And then if you look at the cos, so we all know sine goes with cosine, tan with cot, and then sec with cosecant. They're exactly the same. The only difference is, which I didn't capture there, they've all got a negative on them. So instead of being u prime, so all of the cosec, cotan, and cosecant have got negatives, are basically negatives of the other one. That's basically it, yeah.
Right.
Do you agree with Magwena and Ishmael? Yes.
You know, sometimes I'm happy that you don't just go through examples without a certain.
Sorry?
I'm happy that you don't go through examples without a certain thing, because you learn new things every workshop.
You learn new things.
Because like, the first time I saw that pitch,
I'm trying to understand I'm trying to follow what you are saying.
He's saying he's happy for the workshop, sir. Understood.
Oh,
Yeah.
okay.
Because
okay.
It's bad.
Yeah, no. I'm happy to hear that, Lerato. I'm happy to hear that. Thank you. Thank you.
So I worked it out as well.
The whole idea is try to make an impact.
Yes, sir.
In the community.
Oh, I got it.
Try to make a difference in this community of ours. So I'm happy. Thank you, Lerato. So everybody seems to agree with this pair of Magwena and Ishmael. Ne? There's no disagreement. Ne?
Yes,
sir. Oh, good.
I even did an intergrad to check the answer, sir.
Oh, okay. Okay. All right.
And I did it differently, but I still got the same answer.
Okay.
Yeah, because I didn't use this method at all, but I got the same answer.
Okay.
Yeah, did it like I basically treated it like I would have treated handling a derivative of a non-inverse, and I actually got the same answer.
Yeah.
Yes, sir.
I'm trying to understand what you just said.
Well, okay.
Can I explain for him, sir?
Yeah, I managed to do it. So
he says he did.
Okay, yeah, go ahead.
Okay, you can take your answer, my man.
Okay, so what I did is I get to the question was find the derivative of the inverse tangent of x squared, and then I basically worked it out in terms as if I would have been working out what's that thing, chain rule. So yeah, I literally worked it out like I'm working out a chain rule problem, and then where it gets a bit tricky, but I figured it out, is that after doing everything, I then had negative 2x multiplied by secant squared x squared over tangent x squared times x squared. But then I also remembered that secant squared x squared is the same as 1 over cos squared x squared, and tangent is sine over cos. And then you literally you cancel out, and then you end up with the negative 2x over sine x squared squared, and it made perfect sense. And that's the beauty of maths. You can do one thing in like a million different ways.
Okay.
Yeah.
Thank you. Lerato, are you happy?
More than I was before we started this topic. Someone warned me, I didn't listen. And I also like to thank them for the warning, because like the denominator, I got 1 plus x to the power of 4. But like numerator, like people will tell you it was 1, still 1. They will tell you how I did it. They know.
I'm happy that you all managed to get the very same answer. Let me double check. Kanye, did you get it? Tando, did you get it?
Yes, I got it, sir.
Magwena, did you get it? Oh, Magwena was with Ismail. Okay, thank you. Now,
no, I didn't.
Tando, did you get it?
No, after they explained, I got it, but at first I didn't get it.
Okay, thank you, my sister. Are you okay now?
Yeah, so what I don't understand, say, is examples on top there that you gave us, because I used that one. So I thought when they say the inverse 10 of x squared, so I squared my...
Tando, I'm listening.
Yeah, I'm saying the mistake that I made, I didn't understand that that square, it only affects x squared only.
Okay, but do you follow now?
Yeah.
Okay, now can I request either Ishmael or Magwena to choose the next pair for the next exercise before I can show it to you? Magwena or Ishmael, any one of you, please choose the next pair.
Makwena, you can go
Okay.
first on this one.
Sorry?
I said I'll let ladies go first, Makwena.
So the pair is Ishmael and Makwena. Simplified. Let's move on.
Or simplified?
Yes, sir.
Because they don't want to choose a pair.
Yes, sir.
No, I'm saying.
And
you
because
hear
she's complaining, sir, it's her.
Magwena, what are you saying? I need to hear what you're saying, my sister.
I said I'm choosing Kanyisile and Erika.
Kanyisile and Erika?
Yes.
Okay, thank you. Erika, Kanyisile?
Yes.
Yes, my sisters, you have been chosen to lead us in this one. Please find the derivative of h of x, which is equals to x squared times the inverse of sine x. Magwena, how many minutes again? I'm still with you. How many minutes, Magwena?
Oh, let me check. First. That's 3. Is it okay?
You are breaking. How many minutes, Magwena?
3.
3. Thank you. Let's request Erika and Kanyi to lead us. We don't know whether they are leading us to Canaan or to Egypt. We'll
Wow.
see.
Let's see.
The ladies will decide where they are leading us to.
All right.
Egypt is.
Hi, Erika.
Hello, Kanye.
How are you?
Good and you?
I'm good. Okay, so this is the answer I got. I'm not sure if it's correct, but if it's correct, thank God. So I got 2x
Yeah.
Times the inverse of sine x
Yes.
plus
Yes.
1 over the root of 1 minus x squared.
You forgot one more thing?
There's one thing missing.
One small thing. One small thing.
I
Look
got
at it
the
again.
same as you. If you use the power rule, if you use the product rule, then that after the plus, you have to times with
Or times
x squared again.
yeah.
Beautiful.
Do you have it, Kanye?
Yeah.
Question, guys.
Yes,
Shoot.
Lerato.
You're telling me there's power rule in the sum.
No, not power. Well, power rule as well, but it's
Product
more
rule.
the product rule.
Mostly product rule.
Yes.
Yeah.
If
Like
you
how do you see these things?
It's simple. It's simple. We have two functions, right? And we know that 2x squared is a function on its own. The inverse of sine x is a function on its own. And of course, they didn't put the product rule sign or anything like that, but we know that since we have two functions, multiplication is happening somewhere there.
Because like I thought x squared inverse of sine x, it's 1.
No.
Can I ask?
Lerati,
I'm not fine, man.
Lerati, usually you see how many x's are there, or how many x's are there, and how many functions can you make with those x's? So there's two x's, so there's the x squared and there's the inverse of sin x.
Can I I'll just do it on my side. You all can continue the product rule and see, because
We can help you out. Where are you getting lost?
No, we
So
don't.
like we can help you out. So that we can help you out.
I don't see products.
You don't see products. Okay, so look at it this way. Let's say the inverse of sine x is a different function. Instead of it being that, let's just say maybe it was 2x squared, something like that. You can see the product rule there, right? So we've got x squared times 2x squared. So the same thing here is happening. Instead of saying 2x squared, we're saying the inverse of sine x. Yeah.
Like, can I ask you a question first?
Yeah.
The answer you got, I'm not sure, because I did this like in the past 30 seconds. Is it like 2x inverse of sine x plus x squared all over root 1 minus x squared?
Yes.
Oh.
Lerato.
Yes, Theo.
You said you were struggling to see the product rule, right?
Yes, I can only identify quotient rule.
Okay, can I try something?
Yes, you can.
Let's try another way to look at this. So let's talk families, right? And then let's talk families, and then let's say if in every family, X is the mother, and whatever's attached to the mother is her children, then we group the mother and the children and we see them as one family. In this case, for the first X, what would be that mother's child?
X squared.
It'll be the squared, right?
Yes.
And then let's say we group those and we put brackets around X squared. For the second family, if the mother's X, what would be that mother's child?
Inverse sine.
There we
inverse.
Go. Yes, and then we group those two together. Now that we've got two brackets, in the first bracket we've got x squared, and that's one family. In the second bracket we've got inverse of sine x. What do you now see?
Wow.
Okay, I understand now. But then I have a question. This one important. Have you done those sums where they go like 2x sine of x, and then you can somehow draw it as one graph? That's the thing.
I don't quite follow. I won't lie. I don't quite follow.
This graph, every time I see a graph, I draw a sketch. Maybe that's why I go wrong.
You know what I think it is?
What is
it? You know what I think it is? And again, I'm no professional and I stand to be corrected by everybody here. Don't overthink it. What do you see? If you look at what do you see? And math is always, and the thing with these things is the problem is the more you overthink it, the more you're gonna go off ramp and go le. You wanna go to Joburg, but you're gonna end up going to Cape Town. So my thing with these things is always, what am I looking at? I'm looking at I'm seeing two functions because the one x is the x squared and the other x is the inverse sine of x. Two things. When I put two things next to each other, product rule. That's it. Don't look too much into it. First look at what you see and work from there. The same way how you know that if you've got two functions, one over the other, and the one function has an x somewhere, the one has an x somewhere, and as long as they're one over the other, you already think quotient rule. Same thing here, two functions next to each other. That means they are multiplied with each other, product rule. Don't overthink it. This is not quantum physics. Don't overthink it. It's calculus 1. Don't overthink it. And that's what I say, where sometimes you, in inverted commas, your issue is you are too smart. So before you start driving, ask yourself, what is this map telling me? This map is saying I'm going la. So don't assume because of where we are, I must be good. No, don't overthink it. You've got this, dude. You always know what to do, but you overthink it, then you confuse yourself. Like I said, we think like children here. We've got an x. That x is attached to the squared. The other x is attached to the arc sign. This means we've got two families next to each other. Two families next to each other, product rule. Do it like that, end of story. Don't overthink it, brother. Don't overthink it.
Okay.
Good.
And Jalirato, don't forget about the basic rules that we learned earlier on. Those rules will go with us until trig functions, exponential functions, logarithmic. Go with them.
No, I did not forget. The thing is, like what you say is like every time I see a question, the moment I see f of x, I see a graph and I sketch it every time. That's for practice when they say sketch the graph. I want those 2 marks. So I always scratch my graphs. So in this case, when I sketched the graph, it was one graph. That's why I did not see the.
Okay, all right. Yeah. Like what do you say? Don't overthink it. Just look at the what you're given and work with what you're given.
Okay, I'll do so. Like, but hopefully on the 7th, I'm not sure. Is it the 7th of October?
Isn't it 20?
I'm not sure. I'll be sharp that day. I won't overthink it.
And if you want to make it easier for yourself, just especially if it's going to be a mental thing for you, just attach brackets next to the 2 functions. Then when you see brackets, you'll always think product rule. Yeah, then you can just add a bracket around x squared and a bracket around arc sine x. Then you're ready. When you see those brackets, even you will know that we are doing product rule. Then you take it from there.
I just saw something. When it's product rule or quotient rule, they use h of x every time.
Oh, no, don't do that.
Oh, don't do that. Don't do that.
Oh, you're doing that thing of yours again. Stop it. Don't do that. They don't always do that. Don't do that.
They can say f of x or bani of x.
And say v of x. Don't do that.
You see, exactly.
Don't do that.
Okay, I want to overthink.
Yes, thank you.
So does anyone disagree with the answer that we have?
Nope, that answer.
Sorry?
Lerato agree.
Okay, the others?
Is there anyone that disagrees?
Yeah, or someone that got a different answer from what we got.
Hello.
Hi.
Sorry, this is Nomis. I had to step out a bit, but I did the question, so I just wanted to verify if we all got the same thing.
Okay, what did you get?
So I have x squared over 1 minus x squared. Sorry, I have x squared in the numerator, and then in the denominator I have the radical sign, and under the radical sign I have 1 minus x squared. Then I have plus 2x, the inverse of sine x.
Okay, yeah, we got the same thing.
Okay, thanks.
Anyone else with a different answer, perhaps?
Thank you, Erika and Kanye. Everybody agrees with what you told them. And then even what you discussed with them. Thank you for that. Now, Ndumiso.
Yes, sir.
Ndumiso.
Yes, sir.
Remember I asked you to choose a partner. Now
yes.
the moment has arrived for you to choose a partner before I can give you these ables that I have for you.
Okay, so can I just quickly go through the
I've got apples, cold drinks, juices, sweets, zimbas. But I just need to give them to you and another person.
Can I go with Lerato, sir? Because I feel like we both need some practice on this one. So at least if we can try the next one and then see where we are with it.
Oh.
I definitely support the choice.
Okay, thank you, brother. Now, here are my cold drinks, the sweets, and everything that you can think of. Even the movie tickets.
Oh.
Yes. Please find the derivative of h of x, which is equal to the inverse of cos of 3x minus 1. Now, a pair has been decided upon. Now, anyone outside the pair, except the pair, please give us the time for working out this.
4 minutes.
Sam,
Hello?
do we need to simplify it to the core or just leave it simple?
Before I respond to your questions, Mrs. Only if simplifying it to the core, others wouldn't get lost in the process.
Okay, thank you, Sam.
Thank you.
I'm done.
Okay, now is Pusiso. The sign of the soil said was done long time ago.
Oh, okay.
Yes, I think you can talk to the son of the soil. And then after that, you can talk to us.
Okay, so sure, Lerato. So this is what I got. I got 3 over, it's -3 over radical sign, and then underneath the radical sign I have 1 minus open bracket 3x minus 1 close bracket raised to the power 2.
Yeah, now one of us. I agree with your answer. Son of the soils.
Ndumiso, please repeat it for us. You said you got?
-3.
-3.
Yeah.
Yes, negative. Don't change. Negative.
Okay. Oh yes, -3. Yes, I agree. Okay, yes, I agree. Sorry, I agree.
The son of the soil is on top.
Mm.
Okay, please go ahead and do. I only captured -3.
Okay, -3 in the numerator, sir.
Mm-hmm.
And then in the denominator I have 1 minus open bracket 3x minus 1 close bracket all raised to the power 2, and then everything is square rooted.
Okay. Please talk to them. You and son of the soil, please talk to us.
Wait, can you just repeat your denominator?
Okay, in the denominator, let me say it like this. I have in the denominator, I have the radical sign.
Yeah.
And then underneath the radical sign, I have 1 minus open bracket 3x minus 1 close bracket raised to the power 2.
Perfect.
Yes. Yes.
I wasn't completely sure about this one, but thanks.
Ndumiso, you need to believe in yourself.
Like, sir, I'll be honest, sir, like this particular section, I don't remember doing it at all. So like, it's one of those things, like, I'm thankful for the reminder, because, okay, it reminded me that I think there was something that I missed. So, yeah, but thank you, sir.
Yes, the most important thing, you need to believe in yourself. Okay, let me say this again. please, please. You see, in this world, let me give you an advice. In this world, if you don't believe in yourself, those others will just brush you by the wayside.
Mm-hmm.
Yes, sir. Thank you, sir.
Please have faith in yourself. Have faith, please, please, please.
Thank you, sir.
Thank you. Someone was talking?
Yes,
Was
I
it
wanted
Lerato?
to ask a question. Yes, if this thing, everything here, it's all to the
Yeah.
power of -1, it's not an inverse. Like
If what?
cos open bracket 3x minus 1 all to the power of -1. That's not the inverse.
I agree with you.
Okay, then it's fine because I was confusing things.
I'm requesting us to stop here, but with this homework. Okay. Now let me go here. 2.7e.5. 2.7e. Okay, I'm only giving you one. Do you see number 1? Under exercise 2.
We did.
It's a photocopy.
Sorry?
Where?
At the same.
I didn't get that.
We did it, that one.
Sorry? You say we did this?
Yeah.
Yes, sir.
Yeah.
Oh, okay. Let's skip it. Let's skip it. What about the second one?
No, we didn't do that.
Oh.
Okay. Okay. So only number 2.
Yes. Oh, so
Yes.
tomorrow we are coming in.
Yes. Sorry?
Are you taking a lesson tomorrow?
Am I ready?
Oh, lesson tomorrow. Are we having it?
Yes.
It's
We are
like
seeing each other tomorrow. Yes.
Monday to Thursday, every week.
Sorry?
Monday to Thursday. Oh,
Monday to Thursday this week.
this week. Okay.
Yes.
So may I ask you something?
Yes, brother.
After the derivatives of inverse trig functions, what are we going to do next?
Okay. Let me quickly go where.
A man must prepare in advance.
Okay, I'll tell you, don't worry. Where should I? Okay, let me come here.
Study plan.
Sorry?
I'm saying study plan. It's a study plan.
Yeah, we have a curriculum. Yeah.
Okay, after this, can you all see my screen?
Yes, sir.
Yes.
Okay, from here, we are coming to derivatives of exponential and logarithmic.
Yes. No problem.
Yes.
Then from there, we will move on to derivative of natural logarithmic functions.
Yes.
Okay.
From there, remember that section in the study guide.
Oh yeah, I remember it. Implicit.
That one, please do me a big favor. Go through it. Then when we get to it, we'll only deal with the exercises that you encountered challenges only.
All right.
Okay.
Then after that, antiderivatives, formulae, then definite integrals. Then we'll move on. Then we'll continue. We'll move on. We'll see how far we get.
All right.
Yes.
Thank you.
As far as the
I
and
see
carry
that we still have a lot to cover. Oh. Yeah. We don't know. We don't know. Let's hope my boss will have mercy on us. Let's hope so. We'll see how far we can move. But my bosses are here. Then with their guidance, then we'll get as far as we can. But what I'm quite sure of is that what we would have covered, if you can do me a big favor, then you'll make it through. Believe me.
Agreed.
Kalisubalana leti.
No, proudly so.
Translation, through the eye of a needle.
No, Theo.
Ah.
So can we agree that we are stopping here and then we'll meet tomorrow?
Sure.
Yes, we can agree.
Yes.
Yes.
All right. On that note, please enjoy the rest of the evening.